Hello again, everyone, and welcome to this episode of Spilling the Tea, where we are exploring everything that is TEE related, trusted execution environments all the way. So if you're new to trusted execution environments, stick around. There's something here for you. And if you're deep in the weeds of the technology, also stick around because we're going to be exploring some pretty interesting topics. I'm Lisa Loud, the Executive Director of Secret Network, and I'm joined by my co-host here, Zoe McFox from Fala Network.
Yes. Hello, everyone. Excited to be back and excited to host a session with you, Lisa, and welcome, Dev.
All right. Our guest today is Dave from Osmosis. And Osmosis has been around the Cosmos space for quite some time. So many of you may already be familiar with Osmosis and with Dave's work. But I would like to give Dave a chance to introduce himself and just talk about what you do at Osmosis.
Hey, everyone, I'm Dave. On Osmosis, I work on a lot of the technical stuff from how we design the blockchains, how we imagine consensus, adapting consensus to give users what they need, from exploring things like privacy to getting lower latencies, or how you change consensus to be the best DEX. And now, more recently, we're also doing another take on how we bring the UX to users who are native to any chain with Polaris. So
Awesome.
I work on everything in the technical backend side of this.
As Lisa mentioned already, you guys, Osmosis is not a new DEX in Cosmos and overall also interchain focused or multi-chain focused. But I know back then when you guys got introduced or even launched in 2021, you had a bold statement of being a privacy-focused DEX, right? So I would like to go a bit back in the times and saying, what did the privacy mean to you guys back in 2021? And how has it maybe also evolved over the years for Osmosis directly and maybe even also Polaris that you're also building in addition?
Yeah. So initially the vision was centered on two parts, I guess: anonymity of user identity and then eliminating MEV. We had was focusing on each one of these. So one of the problems I think familiar to kind of everyone is that today, if you use a blockchain, your address is linked to every single action you want. This is very bad for making the world we want to live in. And in particular, sometimes you have issues convincing people why should they care about privacy? Beyond that you don't want people to see your bank balance. But for trading in particular, it's extremely bad because you don't want things like your stop losses or your liquidation thresholds to be public. This gets you things like stop loss hunts on exchanges, where there it's private. It's far worse when it's on chain and public. And second, it leaks your trading strategy if you're like a market maker or something. You need a lot of this. Yeah, you need a lot of privacy here to solve both of these. So the vision on that front is, okay, let's get anonymity by having a shielded pool where make a Zcash style shielded pool and then have all actions be public but coming from the pool. So then that would this would solve don't have a public bank balance and don't leak your trading strategy. Then you need much more cleverness around composability with either MPC or TEs to get to solve these liquidation threshold problems. Then the second aspect of privacy was solving a lot of MEV problems, where we made this framework of what we thought was positive MEV and what's negative. And then a lot of the negative ones really came from the market kind of gets to know what you want to do before it executes. I can see if I see your trade and there's some slippage bound, hey, I can go sandwich you. Well, solution, let's not let people see what you're about to do before it's known. So let's have, then our preferred solution was let's encrypt all your transactions to the validators. Validators kind of commit to a sequencing of it, and then decrypt it in consensus. And since I think the meta shifted and comfort TEs shifted, so now another solution is just encrypt your TE and then decrypt after it's into a block.
Yeah, just for some of our listeners, can you define what MEV means?
Oh, yeah. MEV, there's been some contention on the price definition is a very contested thing. But the first acronym was minor extractable value. In general, it's what could you do if you can reorder other people's transactions or see their transaction and do something else based off of its contents.
Right.
So one thing you could do is two common examples is if you see some arbitrage on chain of like, I don't know, you buy an apple for $5, sell it for $6. Someone's just gonna go buy all the apples at $5 and sell it at $6, take that dollar difference. Well, if someone did that, and you could see that they're going to do it, you could look at the transaction and say, hey, I'm going to do that instead. You didn't figure out the arbitrage. You just saw someone else did it, and you could get into the on-chain faster.
Right. You can swoop in and take that arbitrage. It is a big weakness of on-chain DEXs in general, not just Osmosis, but in general, Uniswap, PancakeSwap, all of them, because of the public nature of the order books or the on-chain activity, essentially. Not really order books, but on-chain activity. So I've had plenty of sandwich arbitrages happen to me and suck out all the value of a particular trade. So have first-hand experience of that painful technique. So you mentioned a little bit about TEs and how TEs can be useful in protecting against front running in Osmosis or Polaris. Do you think that TEs are the best solution out there?
So for front running in particular, or these MEV attacks, the problem is what's the cost for the problem with everything for TEs is twofold. One is you shouldn't use these for long-term privacy guarantees, but thankfully MEV resistance doesn't have that. It's potentially a good fit. The other thing is, what is the perceived cost to secretly break a TE? And I think there's not like a consensus number that people have agreed on, but it's kind of subjective of everyone has their own opinion on it. And you kind of make your own opinion based off of your extrapolation of research teams and the like, where, what have they managed to break in the past and at what rate and what funding? To me, at least, it feels very reasonable to say like, okay, for maybe it's the cost to break any TE is a couple million. So then if any TE can be used to decrypt transactions and exploit MEV, then this could be a bad spot. MEV revenue across all chains is in the hundreds of millions a year. So there it feels like there's incompatibility of, okay, could someone just silently break one TE and then still exploit all MEV? Now there's a couple of workarounds you could do. It's like, maybe it's not any TE, maybe you need TEs owned by these designated people, like kind of proof of stake or proof of authority on top, or other strategies you could do.
Other strategies of what? What do you mean? To make the TEs more secure, kind of?
I'd like to de-risk the idea of breaking one. Okay, so you could do a POA assumption. You don't have to make a public network that can decrypt a transaction. You could make it more centralized of, hey, only these few nodes can do something. The second thing is, here's the second one. It's auditability of, can you post facto, post decryption kind of tell did things got exploited? Because you can see sandwiches.
Right.
And suddenly a lot of these transactions are getting sandwiched. This is suspicious. Or, hey, I found a bunch of liquidations. I used to be able to get in. Now I can't. But then someone else is getting liquidations at almost the exact same transactions with almost the exact same content I'm making. Maybe this implies that someone has broken it. So you can use, I run those two arguments, like POA-ness and more TEs. So it's like not just you break one TE and join, but rather you have to break 3 out of these 5 people's TEs.
Right.
Or you can say, hey, if something's broken, can I tell after the fact? And then kind of governance respond.
Right. So it's, in a way, it's like MPC plus TE.
Yeah.
That's what I hear as well, because you mentioned the MPC, multi-party computation, in the beginning as well. So this was also the approach that you followed throughout the years, Dev, for Osmosis?
Yeah, we spent a lot of time prototyping, getting pretty close to deploying MPC for threshold decryption. This one didn't end up being deployed because of some Tenor consensus stuff. We still have heavy interest in getting the MV resistance out. For anonymity things, where our plan is still around this more Zcash style thing, I can talk about that of interest. That's not really that one's not really TE related.
Yeah, that's okay. You can talk about how you're using ZK as well.
Yeah. Okay. So then for the goal of get all addresses anonymized, today there's a couple solutions that's use Penumbra, Namada, or Zcash, where Penumbra and Namada you could use any asset to start a transaction, but you kind of have a problem right now, which is you have to use a dedicated ZK wall. So, actually, no, our solution doesn't involve TEs, my bad. So, idea, we want you to be able to use any wallet you already have. How do we get you to be able to upgrade your MetaMask or Kepler to now be able to do ZK things? Maybe we're really a sacrifice, you don't get to see your balance in the front end, but otherwise it should feel fully owned by you. Well, idea, what if we're calling these privacy vaults? The idea is that let's have you create a new ZK key, and then let's go upload this key to an MPC committee that's constrained by TEs. I make a new key, I share it to say 10 people, and you need 5 of the 10 of them to get together to reconstruct. These people have the keys in such a way that they can only access the decryption share within a TE if I sign a transaction saying I want to do something. Like I have to sign, say, do a swap from, I don't know, Sol to ETH, and then they check it goes to their TEs. Each of them checks a signature. Says, oh, okay, the signature checks out. We will share the decryption shares to each other, and then construct the ZK transaction. Right. So now we lift the whole problem of needing new wallets to people. Well, people need new wallets to instead this MPC committee who uses TEs for this. So we get this great long we get the security of it feels like very self-owned because it is self-owned unless you broke the TEs for this committee. And this is actually stronger than a normal blockchain where, you know, if I wanted to break a Tendermint chain and steal all your money on there, I would have to go corrupt, let's say 2/3 of those validators. Well, here, okay, let's make this MPC committee a validator set. Then I'd have to go corrupt 2/3 of the validator sets and break the TEs on each of them.
Right. I think this is a great illustration of the fact that all of these security protocols on chain are not really competitive protocols. They're not competitive solutions. They're different parts of the solution I've found that in almost every case, when you combine 2 or more of these different encryption schemes, then you end up with a stronger security. The 4 that we normally talk about are ZK, zero knowledge, FHE, which is fully homomorphic encryption, MPC, multi-party compute, and then TEEs. And at Secret, we're using TEs plus we're also using some FHE for obscuring our RAM access as well. And I know Fala is using multiple types of computation as well. Did you want to talk about that?
I mean, the very exciting use case are really also verifying ZK or ZK circuits within TEs, right? Similar, like not exactly, but like a use case that Dev just explained, where you have like a, let's say, multi-party or a multi-factor authorization and also multi-party verification. So this is the interesting part. If you have the ZK verification in a TE, where you can accelerate the verification part because you take it off-chain, verify it there faster and a bit cheaper, and you can see it as a 2FA as well. So I think these are very cool use cases that we do in Fala. And the combination of TE and FHE is also, a similar approach because you have the combination of like on-chain and off-chain verification. But I believe ZK and TE is just something that's very tangible at the moment and that people would integrate much more than the FHE part, I would say. Yeah. And of course, multi-party computation, I think is interesting. I mean, you guys integrated, right, as Osmosis with this approach, where in the end, the TE, I think, is always the underlying hardware that can enable all of these cryptographic mechanisms. And I think at the moment, it's just about the fastness and the cheaper execution. So this is where it would shine at the moment.
Yeah, I think like TEs are great because they can kind of compose anything. You can take anything with security assumption X, add TEs to it, and now it's strictly stronger security assumption. Especially valuable for authorization or things that are custodial, or could be custodial if funds could be stolen if the assumptions break.
So did you also, over the years, because trusted execution environments were not really accepted in 2021, you also work closely with Secret in the Cosmos ecosystem. How do your competitors or other DEXs actually kept up? Did you do some research on this and always thought, okay, how can Osmosis be like the really most privacy-focused DEX, not only in Cosmos, but multi-chain focused? And how do maybe other DEXs are doing it at the moment, Dev?
Yeah, at the moment, I'm familiar with 3 other people doing like privacy-related things. There's Penumbra, who is doing Penumbra is doing 2 things. They do a shielded pool for address anonymity using a custom extension, and they do another MEV solution. I didn't really talk about MEV solution. They do another MEV solution for having trades batched together, and it's actually the only public knowledge to the whole market is the batch amount traded per block versus like having every individual trade. Then another project that's doing things is like the Renegade finance team, where they're making they've made a dark pool where the idea is, okay, let's not have any public knowledge be known to everybody. It's just going to be known to some committee, and that committee will at some interval release knowledge to everyone else around about that dark pool, the private markets state. For that, they're using MPC for everything. I guess there's also like this Ethereum supply chain for MEV, which is then using the Flashbot's work, where you use T's and TE builders to bundle transactions that, and there it's more around people who are trying to like, get MEV guarantees than are trying to acquire MEV opportunities, like getting some knowledge that you're not going to be sniped by the builder. Or for users, you can use a separate endpoint, which then kind of promises, hey, no sandwiching is going to happen here, because the T doesn't let other people see your transaction.
Yeah, bundling is an important development that I'm seeing a lot of different projects embrace because of, it's not just the MEV protection, I think, that you mentioned. It's also the fact that it can be faster, cheaper if gas is expensive as well, and just more efficient. Blockchain, we're trying to make blockchains efficient now, right? We figured out the use cases for them, but they're still a little slow. I just wanted to touch a little bit on the kind of user data and privacy. So there's sensitive data involved in trading patterns, trading algorithms, and portfolio details in a world where data is increasingly scrutinized. And we can even talk about AI here, because AI makes everything more intense in terms of data, in terms of exposure. The ability to read and digest a lot of data at once is kind of scary. How important is confidential computing for a DEX like Osmosis, and could Secret Network's privacy-preserving solutions support compliance with like the emerging global data protection regulations?
Yeah, I think confidential computing is key. Like in general, I think getting people to own their own data and switching the paradigm of like companies owning it or all your data being fully public is key. That this is only getting more important every passing week, every new base model result, or every new as AI improves, the ability to like do stuff with your data is only increasing. So we need to start adapting things to get the data that's, that you emit verifiable, and switching who owns it. So you don't make it publicly accessible by default. So yeah, I dream of a world where we, I own all my data and I get to share kind of access with apps. Or when an app needs personalization for me, maybe it talks to my own AI model, or like I have something that owns my data. It's an AI model, and my device gets to federate this access. App wants personalization using Model X. Okay, send me your fine-tuned model, and I get to my device, and then my device is in some has some enclave that then puts in my personal data and achieves the optimized app experience. It's not that the backend gets. You don't want ChatGPT or Anthropic or Twitter, trying to get all your data across everything in your life, like your on-chain finance stuff, etc. So maybe back to the more concrete question you're asking about, just like how much compute on chain. This is a big part of it as well, where some things for at least for the finance use case of crypto, like several of the big things you need is some level of public state about the whole market. Like it'd be crazy to be building like perps dexes or leverage and not know what's the total debt in the system. You want every individual's like liquidation threshold to be kept private, because otherwise, then there are problems. So confidential compute is the primitive you need to start fixing that. Now, there's maybe efficiency optimizations of like, how do you break this up? But no, you definitely need confidential compute to achieve that result.
Yeah, I love your point about being able to aggregate data and analytics, because you do need to know what's going on at a meta level, at a macro level in your system and in the market, but you don't want individual strategies to be exposed. Still, like that, it's a fine line to walk. And I know some projects building on Secret who are absolutely against sharing any kind of rolled up metrics because they feel it compromises their users' privacy on trading. Other projects where, not on Secret, but other projects where everything is just completely open, and there's got to be a middle ground where you can do some analytics, but you don't have to expose. I love that point that you brought up.
What's kind of interesting is there's actually a lot to learn from this decentralized world of, at a user level, if you're not worried about a centralized exchange company and whoever they give data to, the public market data actually does have decent privacy guarantees. where open interest is batched. You don't get to see like every single trade. There's actually a Twitter thread of, we had the record amount of liquidations in crypto not that long ago, last couple weeks. And there's like, one site, the most commonly used site was saying, it's $2 billion liquidation. And there's a guy who is CEO of one of the big exchanges saying, no, we alone had 5 billion, or I don't know, that might have the numbers off, more than the publicly stated amount. Your publicly stated amount was because exchanges were reporting kind of the net every minute, where not every single liquidation itemized. It's like, hey, there's this difference between what's the data being reported versus internal. It also gives you, different
Data
guarantees.
is highly susceptible to manipulation.
Yeah. So now the ideal would be, let's go make these very public, decentralized markets that are verifiable the whole way through. Then maybe we get these aggregate stats. I don't know. Is it every 5 minutes? Is it every hour? I mean, I think maybe it depends on the exact details of what we're talking about.
So I wanted to move to AI because both Secret Network and Fala have moved into the AI space in a big way. So Zoe, what do you think about how AI relates to this conversation?
Yeah, definitely. DeFi, we can call it, right? A new narrative, 2025, as each year coming up. Yeah, AI in DeFi, I think it's very, very cool from my perspective. But Dave, you can talk much more about this, where you see automation processes. I think what AI would bring into DeFi at the moment is automating most of the processes, right, for the DeFi user. And then again, we have to see how do these agents that automate processes for us are either fully autonomous or medium autonomous, and how do we can also do these or bring these workflows not necessarily completely public on the blockchain. How do we verify this, right? So this is, I think, what's very important or very interesting in the DeFi space. The privacy part actually makes or is much more needed than we thought about privacy in DeFi maybe before, right? Bringing the AI into it. So maybe a question to you, over Dev, what kind of processes, workflows, if you want to call it like this, do you see being more efficient done with AI in DeFi?
Okay, interesting. I think AI is mostly giving kind of client-side properties in DeFi. Like, hey, I'm a user. How can I switch to a world of having much more understandable transactions, understandable content, and I think using like the experience of signing a thing in Phantom or MetaMask is terrifying, honestly. Of like, there's a balance simulation, and then the content of what you're signing is gibberish. You get like some random hex string. Okay, well, first use, at least get like that to be an English sentence or something that you can parse. But then the way we use it, we have UIs for all this stuff, is probably going to adapt massively. What's the interface for doing actions, and how do I experience my portfolio? How do I get it customized to being ideal for me?
Right.
I actually don't see as much happening on chain for DeFi. I always classify properties involve kind of convincing me of something that it's done correctly. That's not giving any guarantee on chain. For on chain this, it's like it have to be something where it's like, hey, I use an ML model, and it matters that that I use an ML model. In a way, it's like we're kind of independent actors. I've only heard of one use case that seemed compelling to me, which was that imagine you running a bridge, where a bridge is like the most the biggest honeypot for hacks, where well, you could have a AI model that can kind of pass or flag for human review a transaction. So say like, hey, we're going to look at where this transaction came from and see, is it the result of a hack? And I don't know, maybe you could train an AI model for this, of seeing like the last 10 steps, the last 10 on-chain steps the transaction came from. And then you can in principle report this with some false positive and successful positive rate. And then if so, you keep this model hidden, and there's some centralized bridge operator who, like, you're going to use their site will like report pass fail. Then you could in principle potentially catch way more hacks, and then get these into human review at the cost of, okay, you have to human review some false positive rate. And so there you want public verifiability, because you don't want to just have some API in the back that's like we tossed a coin for if you need a review or not. False positives for human review really suck. But I actually haven't heard of many use cases beyond that, unless there's there's a philosophical one of, do we want autonomous AI, which I think might be a lot of the AI narrative or AI crypto narrative. But I think that's more like philosophical, not like we actually have a demand for knowing it's really an AI model. Maybe that is it's intrinsically a value, but it's not like it's not app facing.
We had talked a little bit before the show, and I think there was some different ideas about the future of AI. I mean, at Secret, I really believe that decentralized AI is where things are going, so autonomous and decentralized AI. And the reason for that is that, and that relates to TEs, because TEs plus, so Intel SGX plus Intel TDX plus the NVIDIA 100 GPU all work together in a way that we can make a decentralized layer one, well, some off-chain workers, but essentially decentralized, confidential, encrypted AI. And I think that's kind of the future because of the fact that, like I said earlier, this ability to digest large amounts of data is very scary. So how do we keep our own data to ourselves? And you had an interesting perspective, Dave, about whether we really need any kind of decentralized AI or whether local AI. Can you talk a little bit about that?
Yeah. So the demand I perceive for privacy stuff is I want to own my data. So I want to build this app-centric experience around me owning my data, but also the reality of, hey, everybody is going to want these AI models to fine-tune stuff. So my imagination is that, okay, let's ignore client-side compute costs for a few minutes. I have this bundle of my personal data that's categorized. I want to use Amazon as an app. So I download Amazon. Amazon maybe sends some model parameters to my enclave or my enclave, and it wants to recommend ads to me. It wants to order what I see. So then I pass in my data to the local model and then run the prioritization algorithm, run the ad recommendation algorithm. It's kind of how I see it working. And then, hey, every action I do on Amazon can kind of add data to my data set that then gets used for my interactions in Amazon and other apps. Now, Amazon, of course, will know whatever I clicked, whatever I bought on Amazon's app, but they won't know what I liked on Twitter or what I swapped on Osmosis. Each of those is logged in my personal data set, but not to Amazon. So it influences recommendation and ads, but not leaking stuff. Now,
that's interesting.
That strawman has a number of problems, but around efficiency and the like maybe for things like search, Amazon's data set is way too big. Even if everything was like T enclave, it would just cost too much bandwidth to tell me all this. So, okay, we're going to have to figure out some situation where the LLM kind of asks a couple of queries to Amazon to gather the set of things that they're potentially interested in, and then, runs ordering, runs ad recommendations. It's not like, it won't be the same, but you can get very similar. Now imagine when I want to Google something, my model runs 20 related queries, and then, so Google has 20 queries, sends me 20 back, and then my model just displays the one I actually cared about.
Cool.
So then, sorry, maybe go back to the question of decentralized or not. Well, to me, what matters is there's one model and set of data that's mine, and I own, and either it's on my own device, or maybe I have one centralized enclave somewhere that has access to this data. I don't know, imagine I rent out an AWS cloud with Intel TDX. I guess it'd really be Microsoft Azure, but whatever. And that enclave environment has my data and will get the model parameters and do stuff, and then pass back to me. I know it's the enclave, I check enclave proofs, but I don't actually see the demand for this to be decentralized, of there's a blockchain of hundreds of people who run stuff.
Right. Yeah. I think that the weakness for me in that scenario is that each person is going to have their own instance of an LLM, and fine-tuning an LLM is not a universal skill. It's not something everyone can do. So being able to train the LLM centrally and even fine-tune it or not centrally, but in a decentralized manner with a lot of different distributed inputs, and then to be able to keep control of your own data going in, your prompts going in, your data going in, and the responses coming back, being able to keep that specific part confidential. I mean, I like to use the example of a therapist You kind of train your therapist on your history, your habits, everything. That's not something, if you had an AI therapist, you don't want that information leaking to everybody. But at the same time, you don't want to have to train your AI on all the therapy, like how therapy works and all the different disciplines and what types of psychoses you might have. You want kind of some crowdsourced training there, but you would still want to keep your own personal specific details private, kind of like what you were saying before about aggregating the information in the DEX without sharing personal trading strategies. You're aggregating the learning of the AI across all the different elements, but you're keeping your personal data private.
I guess there's maybe two parts. Oh,
yeah,
go ahead. Maybe there's two parts to this of like, are you getting any sort of distributed learning of let's say here's all my Amazon actions and then here's all of your Amazon actions. Is there any world where both of our updates funnel to like getting both our models to learn off each other's Amazon things?
Yeah, that's what I'm imagining. That's what I'm imagining as the ideal world.
I imagine a decent amount of this is coming from Amazon themselves doing the fine tuning of like Amazon fine tunes the model for their app.
But then they have access to all the data. I want a model where they don't have access to it, but the fine tuning does take place over aggregated data, but Amazon just gets the results.
But Amazon will see whatever I end up purchasing, right? That is the they can't fundamentally can't get around the app backend knowing whatever decision I end up making. So there they get this chance to fine tune. Now maybe now we want to hide or like manage things around is they shouldn't get to what's their knowledge of my Twitter or that influences their fine tuning ability.
Yeah.
But there's not really a good way for maybe easy statistics we can kind of batch data together of like, what's the average age in this neighborhood? Well, we can add some noise to every house's age measurement and then still average and say like the noise risk bar.
But there is, if you have an autonomous agent inside a TEE doing that work, it can receive all that information, but no one can, inside the TEE, all the information is available, but you can't get any individual information out of that TEE unless you own that data. That's
okay. So you're suggesting that what if there's a situation where I have the entirety of my user data inside this TE, and then Amazon, you can go run this fine-tuning algorithm off of everybody's full data. Like everyone's full data is still being passed in, but it's all enclave. So then this training.
Yeah, exactly. That's the goal.
to other ideas for AI and DeFi. If we go 2 levels up from the infra, I think also the agents or walls within an agent, right, would be definitely need to be hosted in a TE. There are some use cases Fala is working on as well. So I think that's a very interesting use case to automate or to have vaults as an agent and then definitely execute them confidentially. And then going one layer more up is like when we talk about the UI, UX, just simple interactions with an agent to execute your trading strategies, right? Or to trade for you or to simply buy ETH when it's under a specific price and so on. So I think this is like the very simple and high level approach just for also different target audience in this and joining us here today, where we have really the AI covering a lot of different levels in the tech stack, I would say, in DeFi. So really the UI, UX for the efficiency. Then we have the agents where you can also automate and then definitely need the confidential part to host these agents because you don't want to put them on the blockchain. And then we have the LLM layer that you guys just discussed in more detail. Yep. Very nice.
Yeah, for the ones you listed, like for the vault management, there you want to know there's this model, not just some human who can rug you, where there's some reason that we're doing a trade at some moment. There's lots of vaults where it is just a human, like a good rug, but people are happy with this. But, the AI one principle, want to de-risk that part. For the client side stuff, I'm actually unclear how important this is. Like when I go ask ChatGPT, I don't actually care that was it a model or a human. Like if a human could type out that response at that quality in 10 seconds, great.
I agree. No. For the UI UX, the highest level part of the layer, I wouldn't say we need the confidentiality, but definitely for the middle layer agents and the LLMs. Agree to that. Yeah.
Yeah.
Yeah. So, I mean, I think the future is going to change a lot over the next few years. We can have this conversation again next year and see, it could be completely different players. But I do think that we're heading to a world where we talk more to our AI than to the other humans in our world, which will be interesting. Okay, do you have any final thoughts to share with us about anything in the world? Where do you think we're going?
Well, I think if no one works on this privacy and data ownership stuff, I think we're going to a world of every megacorp competes to get all your data and perfectly attempts to mimic you. But I think the world we prefer and we're building for is now this flipped around paradigm of we own our data, and hey, like apps should be apps are meant to serve us as people, and where you go to Twitter and you should get to be able to control what your feed is rather than Twitter really dictating this.
Well said. That is a very, I think we can all agree on that. So let's end on that note. Thank you so much, Dave, for joining us today. And this is Spilling the Tea, podcast about all things TEE, secure enclaves, and trusted execution environments. Come back, tune in again. We will be hosting another episode very soon.
Thank you, everyone. See you soon.
Thanks so much for listening. Thanks for Lisa and Zoe for hosting.